Hey guys, welcome back. So in today's section, we are going to be covering properties of rational functions, okay? In this section, when we're done, we should be able to complete the following objectives. So you guys should be able to find the domain of a rational function. You guys should be able to find vertical asymptotes of a rational function. And you should also be able to find horizontal and or oblique asymptotes of a rational function, okay? So these are our goals. So the first thing we want to go over is we want to look at the definition of a rational function. Okay. So by definition, it says that ratios of integers are called rational functions or rational numbers. Okay. Similarly, ratios of polynomial functions are called rational functions. So the best way that I like to think about this are rational functions are anything that look like fractions. So if it looks like a fraction, then it's a rational function. So what I mean by it looks like a fraction is that your problem is going to have a numerator and it's also going to have a denominator or a top and bottom, just like a fraction would. Now, if you look into the numerators and the denominators, they are polynomial functions. So what we studied in the previous sections, all right, nothing in these numerators and denominators look like fractions. Their powers are positive. They're listed in descending order, which is from highest degree to lowest. So everything in this particular section is going to look like a fraction. Okay, so the formal definition says a rational function is a function of the form r of x equals p of x over q of x, where p and q are polynomial functions, and q is not the zero polynomial. The domain of a rational function is a set of all real numbers except those for which the denominator q is equal to 0. Okay, so we remember when we are looking for a domain, okay, remember the domain is talking about the x values. So when they're asking you to find the domain of a rational function, they're asking you which x values can you plug into the denominator and it not give you a 0. Okay, so we have to keep that in mind. Remember that the domain for polynomial functions were all real numbers. So this is a major difference between rational functions and polynomial functions. Okay, so the first thing we're going to do, we're going to practice finding the domain. So I have a couple of problems here. So let's go through and practice finding the domain. So let me change my pen color. All right, so let's do A first. Okay, so A says find the domain of the following rational functions. R of x equals 2x squared minus 4 over x plus 5. So the first thing, the domain said that you can plug in anything into this function as long as it doesn't make the denominator 0. So we need to find out what those values are. So for this particular problem, I'm going to set the denominator equal to 0. And I'm going to solve for x. So the first thing I'm going to do is subtract 5 from both sides. So x equals negative 5. So what that tells me is that I can plug in anything I want into that function as long as x doesn't equal negative 5, because negative 5 makes the denominator 0. So when you're writing these domain problems, you're going to be writing them in either set builder notation or you're going to be using interval notation. So you just have to be prepared for how they ask for your answer. All right. So if I were to write this in set builder notation, remember set builder starts off with the brace, not squiggly. You want to make sure you're going to use your variable in question, which is x. And we want to tell our reader that you can plug in anything you want except for x equals negative 5. So we're going to draw our line such that x does not equal negative 5, close brace. So that's how we would write the domain in set builder. If we go to do the same problem, we want to write the answer in interval notation, okay? We're going to write parentheses, negative infinity to negative 5, parentheses, because we're not including negative 5, union, negative 5 to infinity, okay? Cool.